All right, today it's time for another exciting lesson in data mining. In this video, we're going to cover the decision trees functionality, which is really the more popular, or let's say the most popular of the methods that are used in Microsoft's data mining toolkit without doing something custom. As we learned in the first data mining video, the first thing we need to do is connect to our Northcraft Analytics BI application for our IT service management or operations management application, which in this case is incident management. We're going to be looking at a very interesting analysis today, which is around breached service targets. So as you know, service level agreements are different for each customer. They could be based on priority or business service or technical service. Availability, really a number of different options there. So it's kind of a broad measure that we're going to be looking at. But we know that a breached service target, which is part of a service level agreement, is always bad. So we're going to use that measure. And we're going to begin with service targets missed, okay, in our data set. And then what we're going to do is bring in the grain, which you've heard us refer to in earlier videos as well. And the grain is essentially the incident number. It's being used as a primary key. It's necessary for these within the data mining tool set to make sure that you have a primary key. And then what you do is bring in the indicators that would potentially predict your metric. So the measure or the metric that we're focusing on, again, is service targets missed, of which we have 9,770. And now we're bringing in the incident number. And you'll notice that not all incidents, obviously, across all of time here, have a 1 indicating a service target miss, so that we pulled the entire pool of incidents. Now what we're going to do is bring in the fields or columns, again, from our business intelligence application, that we may believe have a hand in the breach service target. Now, one of the things I really love to use, and we won't in this case to protect the anonymity of the data set, is the assignee involved in the incident. We're not going to use that today, but we are going to stick with something specific. We are going to use something specific. We're going to use product name, which is a little bit more effective than using CI name, although you can use CI name as well. In fact, you've probably used both, and it doesn't hurt you to use really anything that you would like. Priority is also a really important predictor and also a measure to be used when mining your data. We'll look at reported source to see, for example, if incidents that come in via email or via an event or via self-service are more likely to have a breached service target associated with them. And I believe we'll just begin with those three. That should be a good starting point. So we'll use those three, bring those into the data set, and you'll notice these OLAP queries are running in the background. Again, this does require the Northcraft BI application, which is built on top of Microsoft Analysis Services. And the reason why we chose that is the total cost of ownership for our customers. And as we mentioned in our commercials, the fact that it supports so many different BI platforms, so that if you use Tableau or Business Objects or Cognos, you have native connectivity with our BI application. Okay, so we brought in some of our predictors, and now we're going to do the first step in data mining, which is to create our mining structure. Creating the mining structure basically allows you to use a different type of query, which is DMX, or a data mining expression. We have three types of expressions that we use in business intelligence that are the most common, which are, of course, SQL, SQL, best for real time. Then we have multidimensional using MDX, and then we have DMX, which is a data mining expression. Now, I probably should have changed my column name to say incident number. I didn't change it, so it is labeled row labels right now. But we've already gone ahead with that, and it really doesn't impact the analysis, so we're just going to move along. Okay, so we've included all the data to create our excuse me, our new structure, and I like to use as much data as possible for testing, so we're going to use 49%. Anything over that and the accurates grow less accurate, interestingly, and we will not put a limit to the number of rows, so it uses all 49,000. I'm going to use a generic range structure name. It's not really important. So what's happening now is we are loading all of the incidents into the structure, and then we're going to use that structure as the basis for creating or laying on top of it our analysis, which will be the decision tree. Now, just kind of briefly on decision trees, what that'll allow us to do is move down a path based on probability of the most likely causes to our service target breach, so that you'll move from left to right down the decision tree to find areas of concern that assist you in decision making. And this is true predictive analysis. And predictive analysis is probably it's a much used term in the market. There's certainly some confusion out there. Just to sum it up, though, really we're determining probability here. We're not determining certainties. The outcomes are much like the weather, akin to weather. There's an 80% chance of rain. In this case, we're going to be saying there's an 80% chance of a service target breach. Okay, so this query that we're running is over the WAN, so the performance in your environment will probably be a little bit faster, but we've just loaded a few 100,000 rows into the structure. Okay, the next is to add the model on top of the structure, and as we mentioned, of course, we're going to be using the decision trees. So the key thing to choose here is one of these out-of-the-box algorithms. And again, we'll use the decision tree. The one thing you want to make sure that you choose here is what we're doing. What we're doing with each of these data elements, and we're using what we'd like to do with service targets missed is predict it only. We're not going to use it as input into the decision model. Okay. So the rest of the fields will act as input, and of course the row labels, which is really the incident number, is the key, indicating that it's basically a unique field. Okay, so now we train the model, and it takes a little bit of time as well, but not quite as long as loading the structure. And there, one thing I didn't point out was that we actually did enable drill through. I'm going to go ahead and collapse this model so it makes a little bit more sense at first. And we can then begin to walk through the decision tree. So first of all, let's start with our low priority incidents and talk through those a little bit. You'll notice that the data mining expression qualifiers are here in the bottom right hand, so you know what you're looking at. So essentially, if the priority is equal to low of the incident, there's a 4% or 5% probability of a breach, which is very low. In other words, we meet essentially 95% of our service level agreements, these of which, of course, are based on priority. We meet 95% of them. Now, that might seem good, although really it's not, because priority low means that we don't necessarily care so much. We've agreed with the business that we don't care so much about these types of incidents. So what you would like to do is obviously have fewer breaches on the high or critical. But you notice here we've got kind of a reverse trend, and So that gives us something to look at. Let's look at these highs. So as I highlight the high, I notice that I'm breaching 30. There's a 33% chance of a breach. I'm only meeting 66% of my highs. That's kind of an issue. So I want to drill down that path. And we're just going to drill one step further down. And what we notice is that if the product name is not equal to this particular healthcare software package, then out of the 6,000 cases that were sampled, 2,100 had a breach. So that's interesting. We'll also notice that we had 50 breaches out of 482 associated with this specific enterprise application. So a little quick math tells us that as we click on that, there's a 10% chance of a breach with that. As I continue to step down, we notice that, well, we have appears to be a pretty great percentage of breaches when the product name is equal to eVault, which is a storage technology. So out of 91 cases, we're looking at a 34% chance of a breach. And you notice that as you move to the right, the logic becomes more and more ornate in these data mining expressions, which is what makes you happy about using these wizards, essentially. One additional thing you can do is, if you're really interested in one particular case, you can right-click and drill through to the model columns, which will then put these all over there for you in your handy Excel spreadsheet. And really, that's the place we want to end this analysis, is to show you that we can actually, again, drill down into these specific cases and now see why they breached. I can filter by only breaches so that I can investigate in these specific incidents and see what we believed caused the breach. And you'll notice that a number of these were created by automated events. So gives you quite an excellent starting point for analysis in determining your IT performance related issues. And I thank you for your time today.